Right, hello guys, welcome back. Adam from Alpaca Animations here. I'm going to do some questions with the moles and gases equations, like I said I'll do 2 days ago. Two things, please use a calculator. And if you don't know what the gas equation is, go back to my previous video. I shall hopefully have it linked in the description if you need to click there and find out what the gas equation is, but I'm going to do a quick run over. P is pressure, so P is the pressure, measured in pascals. V is volume, measured in meters cubed. N is moles. R is a gas constant, which is 8.31 joules per Kelvin mole. And T is temperature. You may see two terms in it. Standard pressure. Sorry for the kind of squashed up writing. Standard pressure, which is 100,000 pascals, and standard temperature, which is 25 degrees Celsius. On this case, as we have to do it, 298 Kelvin. Right, now I do that, I want you all to make sure you have a calculator. If you guys have a physical calculator, but are doing this on a form of electronic device which does have access to the internet, Desmos has a great calculator. The Google one works. The Google one will work for this one. Please try not to do this in your head. It is very difficult, and I can guarantee you'll be very, very, very off. Right, let's start off with the first question then. So calculate the volume that 0.4 moles of an ideal gas occupancy is at 100 degrees Celsius and a pressure of 1,000 kilopascals. So, first of all, we need to extract some information. We want to look for any statistics and what those statistics mean. So in this case, we have 0.4 moles. We have 1,000 degrees centigrade and a pressure of 1,000 kilopascals. Once you have that, you want to look for you'll look for what we're calculating, which in this case, in our case, is the volume here. So let's punch let's put all the numbers that we know into the calculator. So first one is a pressure. I can actually switch my pen over. The pressure, which is in 1,000 kilopascals, which we need to convert to a normal pascal, so we need to times this by 1,000 to get 1,000,000 pascals. Right. What else? Volume, which we are calculating. So I'll leave that as X. N, our moles, which has been so kind and has already been given to us. But in the case you don't get given to it, you just do the standard moles calculator, which is just mass over FM. So just for a single atom, it's this number, the atomic mass. And in a compound, it'll be everything. It'll be all the atomic masses added together. So if we go for like H2O, we see the hydrogen has an atomic mass of 1 and the oxygen has an atomic mass of 16. In this case, it's 2 hydrogens, 1 oxygen, 18. So that'll be the RFM for water. So in this case, we don't need to do any of that. We've already got it, 0.400 moles. Next, we want the gas constant, which we already know is a 0.31 joules per Kelvin mole. And we need a temperature. Just note this will potentially be a long video. We can't do it in Celsius, so we need to convert into Kelvin by 273. 373 Kelvin. Right. So now we know that. We know our pressures. We need to rearrange the equation, so we know what we're doing. We're looking for the volume in this case. So we need to divide this by the pressure. So the equation would be 0.4 times the gas constant, 8.31, times by our temperature, and divide this all by 1,000,000. So the actual equation would be, in this case, is N T over P will get you your V. So right, give me a second whilst I type this into a calculator. Right, I am back, and in this case, the answer was 0.01239,852. Okay, clearly we can't leave that as the answer. So where do we go? We need to figure out how many significant figures or decimal places. Now, if we note in here, we can see this goes up to 3 significant figures or 3 decimal places. In this case, I'm going to go to 3 significant figures. So this would go down to 0.00124 meters cubed. Volume is measured in meters cubed, as you can see there. So that's how you'd work out for the volume. So quick recap over it again. Analyze the question. Figure out, get all the main bits first. So get the main bits. So if you have a moles, get the moles. If you have a temperature, get the temperature. If you have a pressure, get the pressure. Figure out what you calculate, which in this case was our volume. And then convert everything. So our pressure wasn't in the pressure we needed, so we need to times that by 1,000 to get our actual pascals. Our volume was our X, which we started calculating. The moles was already calculated for us, kindly, so it's 0.4 moles. The gas constant, which is 8.31 joules per 8.31 joules Kelvin per mole. Temperature was in Celsius, but we need to add 273 to correct Kelvin, which then we punch into an equation to get our final answer of 0.00124. If you guys would like me to do a episode on how to rearrange equations, I'll go through all the equations. I'll go through the moles equation first. Just ask. I don't mind going through it. That's all I need. Right. Next one. Okay. All right. Here's the next question. How many moles of gas occupy 19,400 centimeters cubed at 27 degrees centigrade at 1 atmospheric pressure? All 3 of those need to be converted. However, we first want to analyze. So what we're looking for, we've got a volume, we have a temperature, and we have a pressure, which I've told you this in the last video. Not told you in this one yet. But I'll show you what it means. In this one, what we're calculating, the moles. We're calculating the moles in this case. So let's punch it all in. Pressure. which we have 1 atmosphere, which is just 100,000 pascals. This basically just means standard pressure. So if you see this, think standard pressure, and that's what it is. That's all 1 atmospheric pressure means. Next one is our volume, which in this case we have. However, it is in centimeters cubed. We need to divide by 1,000,000. Right. So it'll be 0.01940. Give me a minute to double check that, because I want to make sure I'm providing you guys with the right information. Don't be afraid to use a calculator for this. The more you use a calculator, the more likely you're going to get this right. And also, do not be afraid to write down what you put into your calculator. Okay, right. Right, I have done it right. N, or moles in this case, is our X. Our R, which is our gas constant. I'm just going to write GS for gas constant from now on. Because I don't have to keep writing it out constantly. Which is 8.31 joules per Kelvin mole. And we have a temperature, which is, in this case, 27 degrees, which we can't do, so we're going to have to add 273, which will create exactly 300 Kelvin. Right, once we have all that, we now need to arrange our equation, which is N equals RT over PV. Let me just double check that, guys. I'm sure that's it. Apologize, guys. I just double checked myself. Nope, I've put that the wrong way around. That's PV over RT. Don't be afraid to double check yourself. I do it all the time. Plus you'll know where to improve yourself when you double check yourself. Anyway, so we know our pressure, 100,000, times by our volume, which in this case is 0.0194. Divide this over our gas constant, 8.31, times by our temperature of 300. Once again, type this into a calculator. Please don't do this in your head. Also, I'm not going to shame you for doing it. It's going to be a lot harder to do it. 200,000 times 0.0194, 8.31 times 300 is 0.7781 78909. Right. Once again, we can't leave it like that. So we need to look for the biggest number, or a number that has several digits in it. That is not a whole number. So in this case, this one, which goes to 3 significant figures. So in this case, we're going to want to go to 3 significant figures. So 0.778 moles. So once again, I'll quickly go over it again. First thing you want to do is you want to get your statistics. So our volume, our temperature, and our pressure. Remember, an atmospheric pressure is our standard pressure. Then figure out what you're calculating, which in this case is the moles. Then you want to convert everything. So 1 atmospheric pressure into 100,000 pascals. Our volume into from the 19,400 to 0.0194 meters cubed. Our moles is what we're calculating, so that remains as X. Our gas constant, which is 8.31 joules per Kelvin per mole. And our temperature, which was 300 Kelvin, because you have to add 273. Once you have that, you want to rearrange the equation so it actually works for this, which in this case was pressure times volume over the gas constants over times temperature, which would give us our moles. Where am I looking for? Right. Once you do that, then you just punch it into a calculator. Then you finally get this. You get your answer. Right, next one. Right, here's the next question. Calculate the pressure that 0.05 moles of gas, which occupies a volume of 200 centimeters cubed, exerts at a temperature of 50 Kelvin. So once again, standard procedure. Get our numbers that we know of. So 0.05 moles, 200 centimeters cubed, and 50 Kelvin. Now we want to figure out what we're calculating, which in this case is pressure. Right. So let's go our equation quickly. PV equals nRT. So pressure is, well, we don't know, so it's going to run like that. The volume we know is 200 centimeters cubed. Now we can't have it like that, so we're going to have to divide that by a million. If you give me a minute, guys. Uh, 200 divided by. Don't be, once again, as for this again, do not be afraid to use a calculator. I use one fairly often. Meters cubed. Moles, which once again is being so kind and given to us as 0.05. And a gas constant, or GC, which once again, 8.31 joules per Kelvin per mole. And last but not least, a temperature. You don't have to write this all out like this. You just wanted to, extract the information and just go like that and highlight it if you don't want to write out yourself, which is understandable. As long as you guys know that this, and this is what you're using in the equation, that's all that mainly matters. So, now I need to take this equation and make it so we can get the pressure, which is not actually add, nRT over V. Will get you pressure. So, let's put in. So our pressure, which is currently X for now, is going to have to equal to N, or 0.05, times by 8.31, times by 50 Kelvin, times by our volume, which is 0.0002. So, if we type that in to a calculator, so 0.05 times 8.31 times 50 divided by 0.0002. Okay. Which we get 103,875 pascals. I'm sure you'd be fine to leave it like that. They haven't really given you a specific thing. But I'm going to go out on a limb and say to three significant figures again. 9 out of 10, it'll be up to either three significant figures, that is a tip, or three decimal places. If the equation's got more than 3 zeros, it'll be this. If it's an equation where there's like more than 3 digits behind the zero, so let's say it's like 0.1256, then it'll be most likely this, which means you'd round this up. Just so you guys can clarify, if you ever get stuck in like, if it doesn't mention, it'll be most likely one of these two. Most of the time they do mention, so I'm going to go with significant figures, so it'll be 104,000 pascals. So that's how you figure it out for pressure. Let's go on to the next one. Right, I am back. I just need quickly check. Right, just need to double check something. Right, anyway, carry on. Right, so first things first, we got another question. 0.140 moles of gas has a volume of 2.00 decimeters cubed at a pressure of 90 kilopascals. Calculate the temperature of the gas. Right, so let's go for the standard procedure. Numbers, which is 0.04 moles, 2.00 decimeters, and 90 kilopascals. Yeah, now I'll figure out what we're actually calculating, what we're actually doing in the picture, which in this point is the temperature. Right. Now we have that, we need to just do some basic maths. I said basic, right. PV equals nRT, once again. So, P, let's start off with pressure, again. In this case, this is 90 kilopascals, which we can't keep, so we need to times by 1,000 to get normal pascals. So it'll be 90. Oh, I'm doing it all wrong here. Be 90,000 pascals. Now we need to do the volume, which is 2.00 decimeters cubed, which we can't have, so we have to divide that by 1,000. Oh. Give me a second. I can do this in my head. I just want to make sure you guys know it's not actually shameful to do this on a calculator. Plus, I like to double check. 2 divided by 0.002 meters cubed. N, our moles, is 0.140. Gas constant, or GC in this case, is once again 8.31 joules per Kelvin per mole. And finally, our temperature, which simply is going to be our X. So now we can't use this equation like this, so we have to arrange it. So our T is equal to PV over NR. Let me just double check that. I'm sure it's correct. Right? Yeah, we found it correct. Right. The temperature. Now I just need to plug this into the equation. So the pressure is 90,000. I mean, times that by our volume, which is 0.002 meters cubed, and divide this over our moles, which in this case is 0.140, times by our gas constant, 8.31. Right? So now I've got to punch this into a calculator. Another thing you shouldn't forget in any of these is the, it's done quite often, so it's not having to go at anyone particular, is now, don't forget your units, because they're actually just as important as the actual answer itself, as it is pretty much the answer. 8.31. Right, so we get an answer of 154.718923, which in this case, look here, this has gone to 3 significant figures. So this is the same over here, 3 significant figures. So in this case, we'll be going to 3 significant figures. So cut off here. So 155 Kelvin. Right, that's pretty much it. That's how to do each of them. That's how to take this equation, and use it in a worded question. Hopefully in the next video I'll do on moles and gases. We'll use an actual chemical equation. That won't be in the next video. The next few videos I'll be doing is gonna be atomic structure. Just to give you guys a break, and me a break from just keep doing this. I'm sorry this video's gone on for almost half an hour. I'd like to finally thank you to whoever's still here and watching. I hope you all remain safe. I hope this has helped you out. Have a good day, guys. I shall see you all later. Bye.